The next topic in the basic of computer networking is network topology, and this is very important topic from the exam point of view, whether it is SSC CGL, CHSL or RRB NTPC. And in this particular chapter, the most important one is the features of the topology and the identification of the topology. Okay, these type of questions are generally asked in the exam. Okay, so let's see the definition of network topology. So we have seen in the first class that a network is basically the interconnection of the nodes which are basically used to exchange the information. Okay, so how they are arranged or how they are connected and cables in the network, it is the network topology. Okay, in short, how the devices are connected to each other, it is called network topology. I repeat once again, how devices are connected to each other is the network topology, and the arrangement or the layout of computer and the cables in the network is called network topology. Okay, and there are basically 5 topology. One more is there, which is we call it as a hybrid topology, which is combination of these topology. So there are basically 5 topologies starting from mesh, star, bus, ring and hybrid topology. Okay, so let's see one by one. The first one is mesh topology. Okay, so in the figure you can see these are the station, or you can say these are the computers or the nodes or the device. They are making a network. Okay, so they are connected to one another. So what is the characteristic of this mesh topology? From the figure itself you can say that every device are connected to every other device. For example, let's see this station. So this station is connected to each and every station in the network. So it is connected to this station, it is connected to this station, it is connected to this station, it is connected to this station. Okay, so the most important characteristic of mesh topology is that every devices or the nodes or the computers are connected to every other devices. Okay, and sometime it is also known as completely connected network. Okay, so the completely connected network is the mesh topology basically. Okay, and it is most reliable network configuration. Why it is most reliable? Suppose one link is broken, this channel is broken, this wire is broken. Even though this channel is broken, station this can send the message to this station via some other route. Okay, so in this way it become a reliable network configuration. And sometime in exam he can ask the number of wires required or number of the channels required, number of path required. Okay, so the formula is n into n minus 1 by 2. Okay, this you can derive easily when everything is connected to each other. It is basically n into n minus 1 by 2. For example, there are 5 stations, so number of wire required will be 5 into 4 divided by 2. It become 10. So you can count it. There are 10 wires are required in the mesh topology having 5 number of nodes. And it is very costly and complex since each device need to be connected to every other device. Okay, so wires need to be laid out, so in that way it become costly and it become complex. Okay, so you need to connect each and every device to each and every other. Okay, so in this way it become complex also. Let's see the next one. It is star topology. So in the star topology, what is the characteristic you are looking in this figure? Yes, the first one is that all the stations, all the computers are connected to central hub. Okay, so all these stations are not connected to each other, but they are connected to the central hub, or it is also known as switch. So this pointer we have seen in CHSL. And why it is called star? So you can make it like that. This is my central hub, and all these PC are connected to each other. So in this way it become a star. Okay, so the most important characteristic is that all these stations are connected to the central hub or the switch. And this type of star topology is very commonly used in local area network. So we have seen different type of network, and local area network is a common network, and it is the star topology which is commonly used in such type of networks. And in this case, the number of wire required will be n-1. For example, we have 4 stations. Okay, so if there are 4 stations, how many wires are required? It is n, not n-1. It is 4, because it is going to be connected to the central hub. So 4 station, 4 wires will be required. Okay. The next one is the drawback. One drawback is there, that if the central hub got failed, it is going to crash the network. Okay, so each station is communicating with each other via central hub. So if central hub is crashed, everything is going to be crashed. Okay, so in this way it become unreliable sort of network. Let's see, the next one is the bus topology. So let's see what is the characteristic of bus topology. And here if you see that all the computer or the station or the nodes are connected on a single cable. Okay, and this single cable is called backbone. Okay, backbone, all these computers are connected to this backbone single main cable. And it uses multi-point connection. We have seen 2 point of connection. One is one-to-one connection and the second one is multi-point. So multiple points the stations are connected. And the problem with this type of network is that if my main line single cable or the backbone cable got fault, it is going to crash the whole network. Since it got crashed, every other station is going to affect, because they are connected to that backbone cable. Okay, next one is the ring topology. Let's see the important characteristic. As the word suggests, all the computer are going to be connected in a circular loop. So you can see in the figure that all the stations are connected to the circular loop, and data travels unidirectionally. Although you can see it can travel in both the direction, but in the ring topology, one of the important characteristic is that data travel unidirectional. Okay, that is sometimes called as a half duplex or simplex. Okay, that we have seen a simplex or half duplex. Okay, and it is using one mechanism that is called token passing mechanism. Okay, so whoever has the token, that machine is going to send the data, and all other station need to listen. Okay, and the problem is that again the device fails, it will lead the network crash. Okay, suppose this device was there. Okay, so if that device got failed, it is going to crash the network, since it is based on the token passing mechanism. The next one is the hybrid topology. As the word suggests, that it is going to be a combination of topologies. Okay, it can be a star with the bus. So as you can see, this is my star topology, since star topology uses a central hub, and the bus using multi-point connectivity. So here it is a combination of both star and the bus. Okay, it can be other also topology.